Okay, so this is what I did is somebody asked about using the fundamental theorem of calculus to find the average value of a function. So this was from section 5.1, where they asked us to use a midpoint rectangle area approximation to find the average value. So there's a little recap here. You probably watched my other video. If not, I'll go through that if you're stuck with it, because this will help. I think that'll help, because then it's just a quick extension. So they wanted me to find the average value of 4 over x on that interval 2 to 10. So what I did is I drew the 2 to 10. I found that was 8. I broke it up into the 4 rectangles, found the midpoint. And then since each one of these rectangles is too wide, I know it's going to be 2 times however high it is. And what's nice about 4 over x, I was just able to drop in that x value and come up with the heights. And so I got those fractions, I added them, and then I had to divide the sum of those fractions by 8, because they wanted to know on average how high is this, what's the area of this function, or how high are those rectangles. And that's what I got. And now that works out to be about, see, I did this earlier, that works out to be about 0.787. And then in section 453 now, they're asking us to do 5354, they're asking us to use that fundamental theorem of calculus. So what we do, what that says, so the theory says, if you're looking for the average value of a function, you are going to find the antiderivative of here. Where did I do this? Here's the generic one, kind of generic. I started to substitute in the function. But what they say is here, let me fix that. If they say, if you want to find the average value of a function on some range, when you have the functions in it, so this is the integrand, the fundamental theorem says, hey, find the antiderivative of that, and then you're going to evaluate that from A to B. So that says, take the antiderivative you just found, find f of the right end, and then subtract f of the left end, and you get some answer. And then because we're looking for the average value, you're going to divide by whatever that distance is. And since this is the distance of 8, we're going to divide that by 8 or multiply it by 1/8. Okay, just like we did with the rectangles, we divided by 8. Same thing, we have an infinite number of rectangles, or what's happening here. So how do you do that here? Well, I wrote out the integral here. I did the 1 over b minus a. So 10 minus 2, 10 minus 2 is 8. And then the antiderivative of something over x is ln x times that something times that constant. And I'm going to evaluate that from 2 to 10. And then what I did is I brought the 4 out in front, and of course that becomes 1/2. And then what's the ln of 10 minus the ln of 2? And if you think about that log property where you're subtracting 2 logarithms of the same base, you can divide the arguments. So that becomes, you didn't see me do that, did you? 10 divided by 2 is 5. Okay, so what I messed up with was I should have written 2 here, not 5. And then 10 divided by 2 is 5 there. So I didn't mess that up. I was going to say my answer was really good. So I didn't know how I messed that up. I see what I messed up. So that's the exact value. And if you grab your calculator, do the natural log of 5, then divide it by 2, you get 0.805. Now my midpoint approximation was 0.787, which is darn close to 0.805. So it wasn't that bad an approximation. But that's how you do this. You'd find the antiderivative, substitute in your 2 values, subtract them, then divide it by how wide that interval is. Okay.